Okay, so we're focusing in this video now that we know what the three definitions of the trig ratios are: sine, cosine, and tangent. We know what they are. We know how to set up an equation using the ratio, the reference angle, and the two correct sides for that ratio, right? If I use sine, I'm supposed to set up opposite over hypotenuse, etc. All right, now what we're going to do is we're going to use this to set up an equation just like we did, and then find a missing side. Okay, so we're going to start with this problem here. And they gave us an angle. They told us one of the angles is 54 degrees. So I'm going to come over here and just kind of highlight the 54 degrees and say, we're standing right there. Okay? If we're standing on this angle, we're going to label our three sides just like we did when we were setting up ratios. This is opposite, adjacent, and hypotenuse. Okay? Those are my three sides. So if I'm looking at my ratios up here, my three of them, and I'm looking at this adjacent side and saying that is completely blank, I know absolutely nothing about the adjacent side, I have to cross off cosine because that uses the adjacent side, and I also have to cross off tangent because that uses the adjacent side. So when I set up my ratios now, they're not going to say, hey, by the way, set up sine. Let's just set up sine and tell me what that one looks like. You're going to have to make the choice about which of the three ratios is most appropriate to set up and solve. And in this case, it has to be sine because I know about opposite, or I'd like to know about opposite, and I know about hypotenuse. So this is a triangle that is appropriate to use the sine ratio. So I'm going to write sine down. I made the choice to use that because opposite and hypotenuse are involved. Okay, I'm going to write down the reference angle. And so the reference angle, again, is referring to what angle did you use when you set up opposite, adjacent, and hypotenuse. And we stood on this 54 degree angle right here. So I'm going to put down the 54. Okay, and then I'm going to set up the ratio. The ratio says set up opposite over hypotenuse. So for us, that's W over 17. Okay, and so if I want to know what W is, right, I need to get W alone, which means multiply away the dividing by 17. Okay, so my problem now says 17 times the sine of 54 is equal to W. And so now the question is, how do we use that information? We know W is equal to 17 times the 54. How do we use that information now to actually get a number, get a useful piece of information? And so we're going to let the calculator do a little bit of work for us. Okay, so I'm going to bring up my calculator. There it is. Okay, and I'm going to clear it out. And so we need to turn this sine of 54. Sine of 54 is like a word. We can't multiply 17 by a word. So we're going to go to our calculator and actually use the buttons. Right? So on your calculator somewhere, you should have the buttons for sine, cosine, and tangent. Okay? You want to make sure that whatever calculator you're using is in degrees mode. So you can see that mine is in degrees mode. You have these other options. So you need to look up, use the manual, find out whatever calculator you're using, make sure you're turned into degrees mode. Right? And so I'm going to type in 54, and I'm going to hit the sine button. Okay, and my calculator is telling me that the sine of 54 degrees is 0.8090, which you can round to 4 decimal places if you want. So I'm going to come over here now and say this is 17 times, really sine of 54, the calculator is claiming is 0.8090, okay, and that equals W. Now I can multiply 17 by that because now it's a number, it's not a word anymore. So I'm just going to come to my calculator again and type in, okay, I'm going to type in the sine of 17. So I'm going to say times 17, and it's claiming that 0.8090 times 17 is equal to about 13, okay, 0.75. Okay, so I know that this side right here, this opposite side, is 13.75. Okay, so if you come and take a look at more examples, the only difference is going to be, again, labeling the sides and figuring out which side you're going to set up. Right, so we're going to go through these first two pretty quickly because you're going to see that they're very similar. So again, 41 degrees is my reference angle. That's the one that they gave to me. So if I label my sides, opposite is through the triangle, that's here. Okay, adjacent is the other leg, okay, and hypotenuse is 11. So when I set this one up, I'm going to look and say, I would like to know about adjacent. Okay, I know the hypotenuse. Adjacent and hypotenuse, if I go back to my three ratios, that's the cosine one. So I'm going to use cosine in this case and say the cosine of 41 is equal to adjacent over hypotenuse. So again, now the solve is pretty similar. I'm going to say times 11 on both sides, times 11 on both sides, and I'm going to go to my calculator, and it says that x should be equal to 11 times whatever the cosine of 41 is, which the calculator knows that for us. So let me bring up my calculator again, and I'm going to type in cosine of, got to bring up my calculator so I can see it. I'm going to type in the cosine of 41, so 41 times cosine, and then I'm going to multiply by 11. Okay, and it's telling me 8.3. So I know that this 11 times the cosine of 41 is equal to 8.3. Okay? So coming over here to this last one, I'm sure you can probably already figure out that this was my tangent example, right? Opposite and adjacent. I don't know about hypotenuse in this case. Tangent is the ratio that uses opposite and adjacent. And so I'm going to say tangent of 64 is equal to x over 7. And so that means that x is equal to 7 times the tangent of 64. And that's because, again, to get rid of dividing by 7, I'm going to do the opposite of dividing by 7. Right? And that equals x. So again, go to my calculator, and I'm going to type in the tangent of 64. My calculator requires that I type 64 first. 64 times tangent, 64 using tangent, times 7, and that equals 14.35. So I'm going to say, in this case, 14.35 is the length of the opposite side. Okay. So coming down to these last examples, right, number 4 and number 5 here. This is just same concept. It's just our solving is going to be a little bit more involved because we need to just the way that we set it up, or the way that we solve it is a little bit different. So again, let's do the setup. Right, this is my opposite side from 36. This is my adjacent. This is my adjacent side. Okay, and the x is my hypotenuse. So it looks like adjacent is blank, and we already saw that that means that I'm going to use sine. Sine uses opposite and hypotenuse. So the sine of 36 is equal to 10 over x. That's opposite over hypotenuse. So when I solve this one, it's like, oh, I can't multiply by 10 now because I'm not dividing by 10. I'm actually dividing by x. So let's solve this one using kind of that same concept. If I'm dividing by x, it looks like I want to multiply by x to get that out of the fraction. Okay, so now let's see what our problem looks like. These will cancel. Okay, and I get that x times the sine of 36 is equal to 10. Right, no more dividing by x. And now, to get x alone, it looks like this says x times something. I want to get rid of that something, so I'm going to divide it away. Sine of 36 gets divided away. Sine of 36, okay? So this will cancel, and it looks like x is equal to 10 divided by the sine of 36. So I'm going to bring up my calculator again, and I'm going to do, okay, 10. Ooh, I got to bring up my calculator too. 10 divided by the sine of 36, which for me, I have to type 36 and then hit the sine button, okay? 10 divided by the sine of 36 is equal to about 17. So we're going to say x is equal to, I'll say 17.01 would be a good example, right? So you can see that just because x ended up in the denominator of my fraction when I set up the ratio, I had to do something a little different. I had to multiply the x to the other side and then divide the sine away, right? So it's a little bit more involved with the solve. So let me show you one more problem, and I'm going to give you a nice little shortcut for this type of problem, something that you can do using what you know about proportions to solve this one. Okay, so in this problem, again, here's my reference angle x, 28, okay? And I'm going to say opposite is 1, right? So this is opposite, okay? And adjacent is w. So it looks like this is a tangent problem, right? We don't know hypotenuse. So I'm going to say the tangent of 28 is equal to 1.0 over w. So again, I have this situation where the variable's in the denominator, and on the left-hand problem, I multiplied both sides by w or by x, and so I could do that, right? But here's a nice little trick just to save you a step. If I remember that tangent is a number, and so I can really put that over 1 if I want, right? I can use a property of proportions that says you're allowed to switch the tangent and the w, and the numerator on one side with the denominator on the other. I can do a swap between these two, and if I do that, it's just going to say w is equal to 1 over 1.0. I'll keep writing because that's what it says up there. 1 over the tangent of 28, right? So you can do a swap in proportions of two numbers that are the extremes or the means, and so that's what I did. So again, I'm just going to go to my calculator, and I'm going to do 1 divided by the tangent of 28, which is equal to about 1.88, right? So if you start noticing these, you can kind of do a little shortcut in your solving, save yourself a step, and you'll find out in this case w is equal to 1.88.